Cool. Looks like number 5 is also using the same graph, but they renamed the graph. Instead of the graph being f prime, it is now f double prime. So let's I pulled out my sine line graph that I created for number 3 and 4. So if you guys want to see how I made that, go back and watch that. But now this is a f double prime graph, or sine line graph, and I know that these are the intervals because that is where f double prime crosses the x-axis. That's where f double prime is equal to 0. In this interval, before -3, f double prime is above the x-axis, so I put a positive here. Between -3 and -1, f double prime is below the x-axis, so I put a negative here, and these are both positive because we're above the x-axis. Okay, now, where do we have inflection points? Where does it have? Then the graph of f has inflection points when, okay, so we have to look and see where the sign changes. It looks like the sign changes at -1 and -3. That's where the sign changes. So that means we only have points of inflection right there. Now number 6. Let's attack this guy with a vengeance. No, I was joking. Sorry. All right, so we're looking for the minimum value for this guy, which is kind of obvious. I mean, we know what x squared looks like. If I were to graph x squared, it looks something like this. We know that there's a minimum value at x equals 0. So what's the point of all this stuff? Let's see. We have this interval right here. Now that's an open interval. Both of these are parentheses, so it's an open interval. Do we have a minimum value in this open interval? If I went from -1 to 1, between there, do we have a minimum value? And the answer is yes, because even though we have open intervals on each of those, we have a critical point at x equals 0. And we can show that we have a critical point by looking at the graph, or we can show that we have a critical point by looking at f prime, which is 2x. And if I set that equal to 0, we get x equals 0. So we have a critical value there. And then we could also show that we're decreasing then increasing on both of those intervals, which means we have a minimum value. So 1 is good. Okay, well, what about this guy? 2 to 3. Now 2 to 3 would be like from here to here, 2 to 3. And so this function from 2 to 3, is there a minimum value? Now, my first reaction is, heck yeah, there is. At 2, we have a minimum value. That would be the smallest value on this interval because we don't care about the rest of the function. We only care about the interval between 2 and 3. But that doesn't work. And the reason why it doesn't work is because it's an open interval at 2. So because we have an open interval here and here, we don't have a minimum value. And that's just by definition. By definition, we have to have a closed interval to have a minimum value. 1 is an exception because we have a critical point right there. Now, so that one doesn't work. Now, what about this one? Now, this one, we have a closed interval at -2. And actually, because it's closed right there, you would think, oh, well, at -2, we're closed. So the function would look something like this. Actually, I should be putting an open dot right here. Because we're closed right here, boom, we got a minimum value. Now, I'm kind of in disagreement with the book right here. I think this is kind of an ambiguous question. But I would say it does have a minimum value because there's no critical points here, and we're closed right here at the -2. But I suppose an argument can be made that because this is open, we don't know what's happening right next to it. I guess this is my theory why the book says this interval is not part of our answer. If we had an open dot here, a closed dot here, I guess theoretically maybe we would have something like this right there, in which case we would have, that could be a minimum value even though it's undefined right there. But the problem is I don't get an undefined value with f prime. So the book says this is the answer. Only one works. But I would disagree because this has one side that is closed. But if you look at the definition, I think they're going off the definition here. The minimum value has to be in a closed interval. I don't know. But the answer is A. But if you know how to find minimum values, with any other problem, you should be fine on a problem like this. Remember to find the critical values and then also test the endpoints of the interval that you're given. Normally you're given an interval that is closed, and you have to test the numbers that are in it along with your critical values to see which one gives you the lowest y or the maximum y.